Advanced Pre-Training Course on Heavy Repair of Refrigeration Cycle. Let's begin the Advanced Pre-Training Course on Heavy Repair of Refrigeration Cycle. The objective of this training course is to enhance reclaim by providing a diagnosis and repair of the faulty refrigeration cycle, clogged cycle, and cleaning in a precise manner. The course targets 1. Provide an accurate explanation on the unit's heavy repair standard process. 2. Be aware of refrigerators' heavy repair reclaim cases and prevent them. 3. Use a measuring instrument and jig to accurately diagnose faulty refrigeration cycle. 4. Use a gas leak detector to diagnose the accurate gas leaking spot. 5. Use a measuring instrument and jig to accurately clear out the blockage by cleaning. The contents. 1. Refrigerator heavy repair standard process. 2. How to prevent heavy repair reclaim. 3. How to diagnose faulty refrigeration cycle. 4. How to diagnose gas leaks. 5. How to clean refrigeration cycle. 6. How to use three-way valve jig. The first chapter is Heavy Repair Standard Process. The first section of this chapter will outline refrigerator heavy repair safety regulations, and the second will go over Heavy Repair Standard Process. First, let me explain R600A Heavy Repair Safety Regulations. Before carrying out the repair, check the refrigerant type specified on the back of the unit or the compressor. The yellow warning sticker on the back of the unit indicates dangers such as fire and explosion. As the refrigerant used for this refrigerator is a flammable gas, take the following precautions when repairing or disposing the appliance. Refer to the details below. As R600A is a flammable refrigerant, handle with extreme caution. Second, heavy repair location and its surrounding environment. Check first if the repair site is well ventilated. If not, ventilate the site before repairing. Check for any fire and heat sources nearby. If there is, remove them before repairing. Because R600A refrigerants are highly flammable, they must not be released indoors. During the repair, mandatory compliance to the heavy repair service standards is required. Third, personal protective equipment. For your safety, ensure to wear personal protective equipment before repairing. The PPE includes safety glasses, arm sleeves, protective gloves, and apron. Fourth, precautions when injecting nitrogen. When conducting a gas leak test, do not inject oxygen in the refrigeration cycle. Otherwise, the pipes of the cycle will explode. When using nitrogen for gas leak test, normal pressure for nitrogen injection is 10 to 20 kg force per square centimeter, or 150 to 280 psi. Note that injecting too much pressure of nitrogen, 25 kgf per centimeter square or higher, will lead to evaporator explosion and accidents. Therefore, you must charge the fixed pressure of nitrogen. Now, let's look at the heavy repair standard process. First, open up both outlets of the three-way valve. Second, remove the refrigerant charged in the refrigerator. Third, completely remove the remaining refrigerant inside the unit. Fourth, connect the lock ring or perform welding repair. Fifth, perform the gas leak test. Sixth, run the vacuum. Seventh, charge the refrigerant. Note that after using three-way valve jig, secure the unit's three-way valve connector. If you have not connected the three-way valve connector, the unit will fail to work properly. The next chapter will explain how to use three-way valve jig. Let me explain heavy repair standard process in detail. 1. How to open up three-way valve. To operate three-way valve, you need a three-way valve jig. There are two types of the three-way valve. One is Saginomiya valve, which is a Japanese brand. The other type is SCD valve, Korean brand. You can open both outlets of the Saginomiya valve without using a separate jig. To open both outlets, method 1. After applying power, turn it off within 6 to 12 seconds. Method 2. After applying power, wrap your hand around the valve and turn off the power after the end of the initial vibration. With SCD valve, both outlets can be opened only with a jig. If the three-way valve does not open in both outlets, residual gas will form due to vacuum failure, causing dew condensation on hotline pipe and poor cooling power. Ensure to open both outlets of the valve, especially when working with bottom freezer refrigerator. 2. Refrigerant removal. Required tools are pinch pliers and refrigerant discharge hose. First, adjust the pinch pliers. Adjust the screw of the pinch pliers to pinch the body of the dryer. At this time, take caution to not damage the blade of the pinch pliers. Second, install the refrigerant discharge hose. Connect the pinch pliers to one end of the hose and place the other end outside the window. At this time, remove any fire or heat sources near the refrigerant discharge hose. Third, remove high-pressure refrigerant. Pinch the dryer body with a pinch pliers to discharge the refrigerant for 10 minutes or more outside the window. At this time, ensure to remove any fire or heat source near the unit in advance. Ensure to use the refrigerant recovery bag when working in a confined area. Fourth, remove low-pressure refrigerant. Pinch through the compressor charging tube with a pinch pliers to emit refrigerant outside the window for 10 minutes or more. Third, remove residual refrigerant. Required tools are pinch pliers, refrigerant discharge hose, vacuum pump, and manifold gauge. First, connect the refrigerant discharge hose to the manifold gauge and connect the vacuum pump to the end of the hose. At this time, you must run the vacuum pump outside. Second, connect the blue and red hose of the gauge to the pinch pliers. Third, connect the pinch pliers to the compressor charging pipe and dryer vacuum port. Fourth, open two valves of the gauge and activate the vacuum pump to run vacuum for 10 minutes or more. 4. Check for gas leaks. Equipment for leak detection are nitrogen, manifold gauge, and soapy water type leak detecting solution. Let's look at the leak detecting order. 1. Connect nitrogen to refrigerator and then open nitrogen tank valve. 2. Open the manifold gauge and charge nitrogen into the unit. 3. Apply refrigerant leak detection solution to the pipe connection area. 4. Bubbles form when leak detection solution is applied on the connection area. At this time, evaporator can explode due to high-pressure nitrogen in response to sudden opening of the valve. Proper pressure is 10 to 20 kgF per centimeter square or 150 to 280 psi. 5. Vacuum. Required tools are vacuum pump and manifold gauge. Let me explain the vacuuming order. 1. Open both outlets of the three-way valve. 2. Connect the blue hose of manifold gauge to the charging tube. 3. Connect the red hose of manifold gauge to dryer. 4. Connect the yellow hose of the manifold gauge to the vacuum pump and then activate the pump. 5. Open both valves of the manifold gauge. 6. Run vacuum for at least 30 minutes. Precautions when vacuuming are 1. Run both high and low vacuum pressure simultaneously. 2. Ensure to run vacuum for at least 30 minutes. Stop vacuum if high and low vacuum pressure is 0.8 torr or lower. 3. If vacuum time is short, normal cooling performance may not be exerted. 4. Improper vacuum may result in many problems such as dew formation on the door gasket, poor cooling, higher electricity bills, and cycle running noise. Let me explain the vacuum pump. Standard vacuum level is 0.05 torr or lower. Check the vacuum pump if the level is higher. The left image shows checking vacuum level by connecting vacuum gauge to the vacuum pump, and the measured vacuum level indicates 0.05 torr, which is normal. 2. A 7 cubic feet per minute or higher vacuum pump is recommended. 7 CFM vacuum pump removes 196 liters of air in 1 minute. 3. If you look at the central image, there is a lack of pump oil. In this case, add oil up to the indicated level and change oil every 6 months. 4. With multiple uses, cartridge gets dirty and degrades performance. In this case, change the oil. 5. If the oil is discolored, change oil. Normally, oil discoloration is caused by moisture in oil. 6. Vacuum level changes depending on the oil state. Normally, the vacuum performance improves by 2 times after changing oil. Let's look at the 7 CFM vacuum pump's vacuum level by time based on vacuum mode. If you look at the left graph, the horizontal axis shows time and the vertical axis shows vacuum level in torr. If you run the vacuum for about 30 minutes, the high and low vacuum level indicates 0.8 torr, which indicates good vacuum condition. Therefore, stop running vacuum if simultaneous high and low vacuum time is 30 minutes or longer, and the high and low vacuum level is 0.8 torr or less. Now, let me explain the charging order of R600A can type refrigerant. Required equipment are charging adapter, electric scale, and refrigerant can. First, measure the total weight of adapter and the can. In this image, the total weight of adapter and can is 317 grams. Second, calculate the refrigerant amount to be discharged. Here is the calculation method when there is 80 grams of refrigerant charged to the unit. The amount of refrigerant charged inside the can, 97 grams, minus the charged amount inside the refrigerator, 80 grams, equals 17 grams. Therefore, you need to remove 17 grams of refrigerant from the can. Third, remove 17 grams from the can to prepare refrigerant for charging. At this time, you should discharge the refrigerant outside the window or use a recovery pump if necessary. Fourth, connect refrigerant to the compressor's charging port. Open the valve and charge refrigerant in a liquid state for 1 minute. Fifth, turn on refrigerator and activate the compressor. 1. Run the compressor for 5 to 10 minutes while checking if the evaporator cools down. 2. Turn off the power, wait for 1 minute, and then remove the charging adapter. 3. Firmly close the charging tube cap by using long nose pliers. Use caution not to perform pipe welding or other hot work after charging refrigerant. There is a risk of explosion. Turn the refrigerant can upside down for charging in its liquid state. Ensure to charge refrigerant to the charging pipe of the compressor. This chapter will look into how to prevent heavy repair reclaim. The first reclaim case is a poor vacuum or overcharged gas due to unremoved frost buildup on the evaporator. The left image shows the upper section of evaporator full of frost buildup. The right image shows liquid refrigerant absorbed into the oil and remaining in the accumulator when the evaporator is in the frozen state. If the frost is not removed, the liquid refrigerant in the accumulator cannot evaporate during vacuum. In other words, the accumulator in frozen state prevents the liquid refrigerant inside from flowing out even after running vacuum, eventually remaining inside. Consequently, this results in poor vacuum that leads to cooling failure. To prevent reclaim, completely remove the frost in the evaporators in freezer and refrigerator with hot water or a steamer before vacuuming. The second case is a poor cooling reclaim due to unremoved frost in the freezer evaporator when replacing the fridge evaporator. The left image shows a bottom freezer refrigerator equipped with two evaporators installed separately in freezer on the bottom compartment and fridge on the top. This reclaim is caused by repeated cooling failure in the freezer after changing the evaporator due to a leak on the fridge evaporator. This problem was caused by running vacuum without having removed the frost on the freezer evaporator. In this case, vacuum cannot be done perfectly due to gas and oil residue in the accumulator. Therefore, when changing the fridge evaporator, check and remove frost in the freezer evaporator first before running the vacuum. To prevent reclaim, ensure to remove all frost on the evaporator before performing vacuum, and run the vacuum for at least 30 minutes. The third case is a reclaim on compressor's compression failure due to uncleaned cycle. The refrigeration cycle was left uncleaned when replacing a faulty compressor for the first time. After 3 months, poor freezing reclaim occurred due to frost buildup on the upper evaporator coils led by faulty compression. The cause of the repeated malfunction was the unclean refrigeration cycle when changing the compressor for the first time. As the far right image shows, if the color of the oil inside the compressor is dark when changing the compressor, you must clean the condenser and hot line. The bottom right image shows the substance removed after cleaning the refrigeration cycle. The fourth case is a poor vacuum causing dew formation on the bottom of the front seat. After analyzing the returned samples, 14 out of 24 returns, 58%, caused by dew formation were found to have returned again due to the same problem after undergoing heavy repair. How to prevent reclaim. Remove the frost on the evaporator in the freezer completely. 2. Vacuum for more than 30 minutes. 3. Run high and low pressure vacuum simultaneously and then charge the refrigerant using low pressure. 4. Use 5 CFM or higher vacuum pump. 5. Open up both outlets of the three-way valve when vacuuming.